Hello, I'm David Mooter, Senior Analyst from Forrester. I'll be talking with you about 6 steps towards EDA maturity. Now, my target audience here is, I'm assuming you're already familiar with the concepts of EDA. You want to implement it in your organization, or maybe you've already taken some first steps, and you want to understand what are the things you should be concerned about. I also want to emphasize these are not meant to be sequential steps, but there are steps that I think you will encounter at some point in your journey, and it's good to start thinking about them up front. So with that, let's get straight into them. So the first step is to include EDA in business strategy. Now, hopefully you're already using APIs in your business strategy. The catch though, or the issue is that REST has limitations. And when you have REST as your primary your primary means of delivering digital strategy, then the limitations of REST become the limitations on your digital business strategy. It's therefore important to move beyond REST to things like event-driven architecture and other patterns to ensure that your technology is maximizing the various ways you can deliver digital business strategy. So let's give an example of that on our next slide. EDA as strategy, data agility. Here you see a simple event-driven sales service publishing its sales events to a broker, and it only has an inventory service subscribing. But as your business changes, you find that you need to implement, say, a product suggestion service comes up next. And advancing further, analytics becomes a requirement, and you want to capture those sales events in an analytics database. Moving further, you onboard B2B business partners who also need access to that data. And finally, perhaps a personalization service that could benefit from that data. And what you see here is that this event stream is essentially acting like a data building block, much like APIs are building blocks of code that you can assemble to advance business objectives. Your event streams become data building blocks that can also advance various business objectives. Now, moving on to the next slide, you can see an example of EDA for enterprise insights. So imagine these 5 event streams you see here are coming from 5 different silos. And these silos in a legacy architecture really couldn't talk to each other. And that's a challenge because these, you can see from the titles, purchase, billing, product search, these are showing activities of your customers. And those silos make it hard for you to see a full 360-degree view of that customer. But of course, you want your AI ML pipelines not to be just on one silo on chat or search. You want them to be on the entire customer activity. And so having event-driven applications, publishing those events to an enterprise broker that's discoverable and accessible across the enterprise enables you to build an AI ML pipeline that pulls inputs from all those silos to build an AI ML model of the customer. Also, mobile APIs. When you think about user experiences, you want to have a unified user experience for your customers. That user experience should reflect your business, not your application silos. And this pattern makes it easy, as you can see in the diagram here, for an example, a mobile UX or other UX APIs to receive those events. They could cache the data on their end so that when those APIs are called, they have a local copy of the entire customer view, not just individual silos that have to go out and retrieve, which opens up questions of responsiveness, stability, and so forth. And also things like personalization, just another example. All right, next is to apply API management principles to your business events. Now, an analogy to give here is that APIs are to code as events are to data. APIs took the application code that was trapped in silos and unlocked that silo. So now other departments, other business partners, your customers can reach into that silo, invoke that code, and extract value from that code. Events do the same thing for your data. And as you may have kind of guessed from some of my previous points, think about an event portal for discovering enterprise events and requesting access to those events, much like API portals. When you think about the use case I had of the data agility, discovering that event stream to onboard new business partners, to accelerate delivery of new applications, new services, that is not possible unless there's visibility into your enterprise business events. And just like APIs, an event portal can also help with that. Next step is don't make events the only programming mode. The key point here is that EDA complements other architectures. I point this out because the first time I presented EDA to, in this case, it was a CIO at a very large Fortune 100 company, the first question he asked me early on was, does this replace APIs? The answer is no. It complements APIs and other architectures. And the reason for that, the second bullet here, is that events do not always create loose coupling. I like to say they couple in the opposite direction of APIs. And we talk about decoupling all the time in IT and programming. And the reality is there's never true decoupling unless two systems don't talk to each other at all. You always have some level of coupling. The question is the type of decoupling / coupling, is that aligned with my use case? And we can see that on the next slide here, where I should just describe how events and APIs couple in opposite directions. So here you see an API service with two clients, and our business changes. And now I have a new API client I build that calls this service. And again, our business changes, and I need to decommission one of these API clients. Well, I can do this without any effect to the API service. So this service is decoupled from the clients. The opposite is not true. If I decommission that service, I just broke all the clients. So the clients are coupled to the service, but the service is decoupled from the clients. That's the direction of your decoupling. Now, suppose I have a client that's producing data that it pushes out via APIs to two different targets. And now I have a third service, a business change. Now I got to push it to a third service. I got to change that API client, which I colored yellow here to show some of the pain. I got to make a change there in the client as I build the service. That doesn't seem great. And moving further, if I have to decommission that first target API service A, then my client will literally break in production if I don't also make a code change in the client. So this is just not a great situation for agility. Now, if we did the event-driven pattern for this, the event producer publishes to the downstreams, advancing to my third event consumer. That event consumer can subscribe without changing the event producer. And again, I can decommission my event consumer A. And as you can see here, the event producer is decoupled from the event consumers, but not the opposite direction. The event consumers are dependent on the producer, and there is a coupling in that direction. So as you think about APIs and event streams and these different architectural patterns, I think it's important to think about how do you want coupling? What's the direction of your coupling for your business use case, and let that drive which of these architectural patterns is best suited for it. So moving on, next is plan for events to span multiple brokers, clouds, and geographies. And the reason for this is that different event streams need different brokers. Sometimes a push model is better, sometimes a pull model is better. Sometimes you need guaranteed delivery. Sometimes best effort is good enough. Sometimes I only want a subscriber to get messages while online, and when it's offline, it's fine if it misses those messages. And different brokers, like if you move towards the left, the guaranteed delivery, those may be more operationally complex brokers than as you progress in this bullet. And so if you don't need guaranteed delivery, do you really want to introduce the complexity a broker like that has. And then the third bullet here is the message replay versus ephemeral. So maybe I have value going back and replaying past messages, maybe to train an AI ML model. Okay, that's great. But if I don't need message replay, again, that broker may be more operationally complex than a broker that has more ephemeral message delivery, where once it's delivered, I can't replay that. Also, second bullet, top level bullet on this is that multi-cloud replication and broker mediation can become messy. Now, I'll return to this messiness in a bit, but I want to emphasize that you will probably have multi-cloud replication. And that's because, on the next slide, legacy data weighs down cloud adoption. And event-driven architecture can help with this. So I have a big legacy on-premise footprint because I'm an established company. And I want to take advantage of public cloud, but all my data is on-premise. That becomes an anchor that weighs down your projects and it makes it hard. Like if I want to put my app in the public cloud, but it is 20 inputs are all on-premise databases, that's kind of challenging, right? So if we move on to our next slide here, you can see how event-driven architecture benefits or accelerates your cloud migration. So here you see an account service that's on premises, that's publishing account events to consumer A and B. And because it's event-driven, it's going to help me out when I want to build consumer C. But I want to build it in the public cloud because it's new, it's modern, that's our enterprise direction for IT. But it also needs the account service data. Well, because the account service is event-driven, I can stand up a broker in my public cloud and use replication between my source broker and my public cloud broker. And now my data is equally accessible both on-premise and in the public cloud. Furthermore, that second consumer B there, I want to migrate that to public cloud. And because my account events are equally accessible on-premise and public cloud, I don't have to worry about the data pipeline. I can just migrate that consumer to the public cloud and worry about any kind of code, microservices, whatever code changes I want to do to make that cloud native, but the data it needs is there. So the key point here is this event-driven approach with replication, it divorces where data is produced from where it's consumed. And going on to the next slide, it breaks the chain of data gravity, allows your projects to more easily fly towards the public cloud. Now, moving on, I want to come back to that point about event replications can get messy. If you're doing all these point-to-point replications and you have multiple cloud regions, maybe multiple on-premise data centers, you can get an ugly spaghetti mess like you see here. Now, moving on, there's this pattern called event mesh that makes it more manageable. The idea is you have the event mesh in between your various brokers. I publish to that event mesh, all my various event sources publish to it. And that event mesh then pushes those events intelligently to the targets, to the clouds where they need to be. That makes these point-to-point replications much easier to manage. And it's something to think about if you think you may end up with a large spaghetti mess of replication around different cloud regions and data centers. Okay. Next step is to know when to choreograph and know when to orchestrate. So what do I mean by choreograph and orchestrate? So orchestration you might be familiar with. That's a common integration pattern where a central workflow tool in response to an event or an invocation, it goes out and retrieves data from different sources, enriches it, transforms it, sends it off somewhere else. Think about your classic enterprise integration patterns. Choreography is accomplishing the same thing, but doing so by publishing an event, and then the next steps in that workflow are triggered by responding to the event. Those steps may publish more events in turn of what they did, which could trigger more steps and so forth. So the first point on this slide is to favor choreography when an integration crosses multiple business processes or teams. And the second point on this slide is to favor orchestration when an integration is confined within one process or team. This is a pattern I've seen in my own research, talking to organizations. And to understand why, I have a few slides to dig into a hypothetical example. So our next slide here, orchestration sometimes hinders agility. You can see a sample orchestrated workflow here. The new accounts process invokes this workflow. And the first thing it does is update billing, then it updates customer, and then that customer system will do a match algorithm if it sees that this is an existing customer that we just update to reflect that there's now a second or third account for this customer. Then we have a branch that will update that customer's loyalty level. But if we just detect that this is not a new customer, that this is our very first account, then the branch would send a welcome email through our email vendor. Now, our business changes as we progress this orchestration. We now want to capture the results of that match into an analytics database to get more business insights. Now, there are two challenges with this. One, I am inserting code in front of other code branches. And so I better regression test to make sure I don't break or have negative side effects on those other code branches. But the testing team, the testers I have available, maybe they're on other priorities, and I can't get them on this right away, and that slows me down. That's not good. And just the fact I need more testing hours in general. Also, that analytics database, I want that as the analytics team, but maybe this orchestration workflow is owned by a different team. Maybe it's owned by the team that owns the new accounts process. And so I have to reach out to a third-party team and compete with their priorities to get my priority done. And we all know that that results in tremendous enterprise slowdowns. All right, so how does choreography address this? So if we go to the next slide, choreography for enterprise agility shows that same flow, but using the choreography pattern. My new accounts process is event-driven. It publishes account-created events. The billing system subscribes and does whatever updates it needs. The customer system also subscribes, does whatever updates and matching it needs. And it also publishes the results of what happened during the matching algorithm. Customer matched, customer not found. Finally, my loyalty system can subscribe to the match events and do its update, and my email process can subscribe to the not found and trigger the welcome email. So now that I have this choreography alternative to the previous slides, how does this help address those two problems I mentioned? Well, if we advance this slide, you can see that I just subscribe my analytics database to those two topics. Well, one thing that should jump out right away is I'm not inserting a code change in front of other steps, so that tester problem kind of goes away. Obviously, there's some testing to make sure I'm getting the data in there, but if I have access to those event brokers, if that read access has been provisioned, I, as the owner of the analytics system, can subscribe to that self-service. Maybe I can do my own testing as well if I'm like a citizen integrator with enough skills there. And now we're moving towards a self-service model that eliminates those enterprise bottlenecks and creates more agility. And so the pattern is what I've seen with my research. When you have processes that span multiple, or I should say integrations that span multiple business processes, multiple teams, that's when choreography has the most value, because you really break apart and decouple those teams from each other. So you don't get those resource and priority contention problems. On the other hand, if it's one process within one business team, it's a very atomic process. I've talked to organizations that try to choreograph those, and they found it decoupled too much. It made it hard to see the big picture of the flow. And they much preferred choreography or orchestration in that situation, because the orchestration shows you the flow. It's easier to see and make your changes deployed all as one unit. And you don't have the downsides of the resource and priority contentions. All right, moving on. Next step, know the event patterns and know when to use them. So Forrester identifies 4 event patterns, and those are event carried state transfer, event notification, hybrid, and event sourcing. So let's dig into these 4 patterns and also when to use them. What are their pros and cons? Because that's the most important thing, is understanding why you want to use a pattern or why you don't want to use a particular pattern. So the first of these patterns is event carried state transfer. And this includes all information about the event state in the message. So I'll give an example. Suppose you're an insurance company and you're publishing events from your policy servicing app about policy renewals, policy changes. Then, like, let's say a policy change to add a driver in a vehicle. The event would include everything about what the policy looked like before those were added and after they were added. So the benefit of this, or one of the benefits, is performance. Because it has all information about the state, subscribers can reproduce the state of the original system without going back to that system and doing a retrieval. They can cache that data locally. And because they're caching locally, the second benefit is polyglot storage. Each subscriber can use their own purpose-built storage. Maybe the source system is a relational database, but one of the subscribers would really benefit from a graph database or an object NoSQL store for whatever unique performance needs it has. A third benefit is business enablement, greater reuse for future use cases. Think about the first point I was making at the top of this presentation about that event stream that then got reused by all those other future use cases and B2B partnerships. Because all information is there, that makes it maximally reusable by future use cases you maybe didn't think of when you originally built that stream. Now, there are some trade-offs. You are pushing complexity onto the subscribers because they have to cache that data. And also, subscribers need to deal with schema changes. When the schema changes, there will be a time period when the subscribers get the old schema and the new, so they need code to handle both of those. Not the end of the world, but just something you want to make sure you consider. Finally, when to use. This is the most common pattern I find in my research. And I would just say default to this pattern unless you see a compelling reason for the next patterns I talk about. The second pattern is event notification. This is a simple alert an event occurred, nothing more. Some high-level metadata. So the insurance example may be the policy number, timestamp, and was it a renewal or a policy change, something like that, but nothing more. So what are some of the advantages? Well, the first one is throughput. Very tiny message size lets you push a lot more data through more easily than the large messages you see with the previous pattern. Second benefit, simplicity. The schema message, or the message schema, is unlikely to change since it's basically like high-level metadata fields. But of course, there are trade-offs. The recipients of this data, they have to go back and retrieve from the system of records to get the current state. And that creates new points of failure and performance degradation opportunities from all those retrieval calls, and also scalability issues. If your downstream systems just don't need state, this may be better for its simplicity and throughput, but probably more commonly I see it when legacy system constraints force it. So that's event notification. Let's move on to our third pattern, what we call hybrid. This is when you include minimal information about the event state in the message. I call it hybrid because it has some state like the first pattern, but it doesn't have all the state. It's trying to minimize the amount for throughput like the notification pattern. So what are the benefits? Well, performance, same as event carried state transfer benefits, but faster throughput due to smaller message sizes. But it has trade-offs, like all architectures. You are coupling the producer with the consumer. The producer is just producing the minimal fields the consumer needs. And that means the producer has knowledge of the consumer. That minimizes its ability to be reused by future consumers that maybe have different needs, need more fields than what you put in there. When to use this, I see it primarily used when latency trumps all else. For example, an airplane engine communicating with an onboard computer. In that case, you want to get those events through as fast as possible. That's more important than the reusability benefit of the first pattern. And I also want to make sure that state is getting there as fast as possible, which makes the notification pattern not beneficial here. The final pattern is event sourcing. This is where the event stream becomes a system of record because you are not deleting messages, generally speaking. And this is the most complex pattern, but the benefit here, the key benefit is message replay enables new capabilities. The downsides, though, are many trade-offs. You push a lot of complexity on the subscribers. Again, the schema change problem, except it's greater because with replayability, there's never a time you can retire an old schema. At least with the first pattern, eventually you can retire it. Your storage costs grow indefinitely. And the immutable nature of the stream creates headaches for data privacy and malformed data. So what do I mean by that? Data privacy. Suddenly, the data I had yesterday was okay, but now today, some legislator passed a law or regulation that says the data in my stream now has a right to be forgotten. How do I deal with that? There are solutions beyond the scope of this discussion. Or malformed data. I had a bug where I published garbage data by accident, and I fixed the bug, but that bad data that got in production, it's in the event stream forever, and you got to deal with that. Now, when do you want to use this? Basically, when message replay has value. App modernization, what I described with the cloud migration, I've seen companies do the same pattern, but to break a monolith into microservices. That's called the strangler pattern. AI ML, real-time analytics, real-time event processing, in-memory cache databases. Like an example, the AI ML company I talked to modernized their call center app with that strangler pattern using the event source eventing pattern. Because they used event sourcing when they were done, besides saving tens of millions of dollars on the modern application, which were their objectives, they found they could do new capabilities they could not do with the old monolith. Particularly, they were able to build AI ML models on the event source, which open up lots of interesting things on improving the customer support, customer relations with the call center. So to recap, number one, include EDA in business strategy. Number two, apply API management principles to your events. Number three, don't make events the only programming mode. Number four, plan for multiple brokers, clouds, and geographies. Number five, know when to use choreography versus orchestration. And number six, know the event patterns. So thank you very much for listening, and I hope you enjoy the rest of your day.